Welcome to the final exam, question number 6, and it asks, in the concrete retaining wall shown below, which it looks like so, the proper placement of reinforcing steel is shown in, and it gives you 4 examples. Well, I'm just going to do a quick, I'm going to draw it in there, and we're going to see which one matches up with our drawing. And when you think about it, here's your retaining wall. You're going to have this active pressure wedge coming in like this, which is going to give you a equivalent load at H divided by 3. I hope that makes sense. And it's actually, I showed it, I have it drawn way too high. It should be like right here. It should, if this is H, then this is H divided by 3. It should be about right there. So I'm a little high. But anyways, and that's going to induce a moment. This is going to be your moment arm. H divided by 3 times PA equals your moment times H over 3. So this is going to want to go that way. So therefore, if it's wanting to go that way, it's going to look like this. And since it's bending over on this side's going to be compression, this side's going to be tension, you want your reinforcing and your tension, since steel is good. So we're going to go ahead and just draw it in there. Alright, now let's think about your heel. And where do you want that reinforcing? Now, I think I've said this in past videos, you want to keep this 90-degree angle. Pretend like it's trying to keep that 90-degree angle. So since this is coming, if this is your without load, and it's coming this way, then your heel will want to go this way. And therefore, your heel will deflect like that. Because this will be, it'll be trying to move this way. So in the same thought process, we want to say that this is tension and this is compression. The inside, I guess, is compression. And I hope that makes sense to you. Just think of a normal beam, what happens when it bends like that, and you can figure it out. Alright, now when we said we want tension, so we want steel and tension, we want our steel and our tension face. So this is what you need it to look like. Let's go. And of course it will come over here and it'll hook in. It'll have to hook in and develop those bars on each side. So this can either come over and down, or this can come over and around, something like this. So let's look at A. A has well, let's do this. A, B, C, D. So at least you can cancel them out. A has steel in the tension on the stem, and it has steel in the tension face on the heel, so it looks good. So I'm going to do a check. How about that? Alright, B, it has reinforcing in the stem where it's supposed to be, but not, it has it down here. So B is incorrect, so we're going to cross out B. No. Okay, C, you look at C. The stem is incorrect, and it looks like this. Sorry. Something like that, where it's both are incorrect. So C is no. And D, it has a stem, but the heel is correct. So D is no. Our answer is A. So that was pretty easy. I know I kind of went the long way. But you can kind of get a feel for this, just knowing which is the tension side. So, or if you know, just means look at them and look and say, I'll take A. But this is, this is a real world situation, so hopefully that helps you. And I guess I'll give you a quick 2-second real world is what I'll typically end up doing is you'll have these longitudinal bars going in, maybe at 12 inches, small. And then sometimes you'll even have, these are all at 12 inches. You'll even have some sort of reinforcing here as well, and maybe it'll come down like that. Kind of depends what you want, but it'll be a number 4 bar. It's not, these are the main, what I would call main reinforcing, and this is more just to make a good cage. But that also depends on what you're designing for, and you'll take a look at it. But on these questions, definitely just take a look at your main steel and make sure that your main steel is good, and everything else you can go from there. I'll see you on question 7.